Yes. Hey guys, good afternoon. So welcome to the Physics 101 lecture. I think 4. It's about today we're going to study and continue the vectors. Let's share the screen. Okay. Can you see and hear me?
Yes, yes, we can.
Okay, very good. So last time what we studied the vectors, and this is lecture 2 and topic 2. And today we're going to continue with the vectors. So what are the vectors? Vector quantity has both magnitude and direction, but on the other hand, we use also scalar quantity, and scalar quantity has only magnitude, and we don't use any direction for these scalar quantities. And we already studied these things, and we also mentioned about the coordinate system. Okay, so there are two types of coordinate system. One of them is Cartesian, and another one is the polar coordinate system. And we study how can we convert from polar to Cartesian or Cartesian to polar coordinates. And another important thing is the properties of vectors. So you can multiply them to the negative sign, or you can change its direction to the opposite to find the opposite direction. So if you take it negative, you find automatically opposite direction. And then what we study, and we study the unit vectors. So this unit vector notation is very important. So for x direction we use I hat, for y direction we use j hat, for z direction we use k hat. Okay, so in the equations we say that write your vector in unit vector notation. So you must use I hat, j hat, and k hat. And then there are some algebraic calculations with vectors. For example, summation. How can you add two vectors to each other? When you are making a summation, always x component with x component and y component is y component. So I hat with I hat, j hat with j hat, like apple with apple and orange with orange. So we already solved this example. And we solved this one also. This one. And lastly, we studied the multiplication of the vectors. So for example, how can you multiply a number, a scalar number, with vector? So you must multiply them directly. So if you multiply z vector with 5, this is a normal ordinary number, you must multiply each of the components of that. So 5 times minus 3, 5 times 5. And we solve also this example. And yes, we are here taking a hike. So a hiker begins a trip by first walking 25 kilometers southeast from her car. She stops and sets up her tent for the night. On the second day, she walks 40 kilometers in a direction 60 degrees north of east, at which point she discovers a forest ranger tower. So, how can you find it? So you must find what the resultant of the displacement vector. So you must add all paths. First walking distance, and after that second day distance, and then you make summation. But you must use directions because the directions are very important. How can you solve it? The first displacement has a magnitude of 25 km and is directed 45 below the point positive x-axis. Why 45? 25 km is given in the equation. They said that southeast, and we know it is exactly on the southeast. It means that 45 degree, because between this south and west, or north and east, or x and y axis, there is 90 degree in the coordinate system. What do I mean? I mean that 1 minute. I mean that this. So between the north and east, this angle is 90 degree. Also this one is 90, this one is 90, and this one is 90. So when you are moving to the what? Southeast, it means that southeast. Okay, so this is 45 and this is also 45. So its components are, you must calculate the components. So there are two components of the vector A. We say that this is, let's say, A, okay, for the first path. So there are x component and y component. So how can you calculate the x component? By multiplying cosine 45 and A cosine 45 gives you 17.7 kilometer to this one. This is AX. And also you must calculate the y component, and this is AY. To calculate the y component, you must multiply by sine theta, and theta is 45. And what happens? You will find minus 17.7 kilometer. Why this is negative? Because it is on the negative y-axis. Because this is positive, this is minus y-axis. And then let's continue with the second day. In the second day, it moves 40 kilometer as a magnitude and 60 degree north of east with angle 60 degree. Here they give you that 60 degree, so you are not taking 45. You must consider 60. At the firstly, you must calculate again the components. So there are two components, x and y components. So this one is bx and this one is by component. So how can you calculate bx component? By using cosine theta. So b is given, theta, you know the theta. So you can put in the calculator and find that x component of the b is 20 kilometer. Then calculate the y component, b times sine theta, and you will find that it is equal to 34.6 kilometer. After you find all the components of the paths, then you can make summation, because you know that summation is between the x component and y component. I hat with I hat, j hat with j hat. So the negative value of ay indicates that the hiker walks in the negative y direction on the first day, and the signs of ax and ay also are evident from the figure. So the signs of the components of B are also confirmed by the diagram. So after you write them, as I said that, you must to find the resultant displacement for the trip. So you find an expression for the resultant in terms of unit vectors. So the resultant displacement for the trip has components given by Rx. So this is for x component. So for the x component, you must use only x component of the vector a and b. So ax plus bx. So 17.7 kilometer plus 20 kilometer is equal to 37.7 kilometer. Then you must calculate y component of r, the resultant displacement. So ay plus by gives you what? Minus 17.7 kilometer plus 34.6 kilometer is equal to 16.9 kilometer. Then you can write it in the unit vector notation. In the unit vector notation, x component, after the x component, you must write I hat plus, don't forget this plus, y component 16.9, and then j hat, okay? And don't forget to write also unit. Unit is kilometer here. So this is the resultant displacement vector for this question. After that, the resultant vector has a magnitude of 41.3 kilometer and is directed 24.1 north of east. The unit of r are in kilometer, which is reasonable for displacement. So how can you calculate, for example, here the magnitude? Magnitude is r equal to, if you want, you can put the absolute value to show it, rx square plus ry square. Okay, you can calculate it, and also you can find angle theta is equal to tangent inverse ry over rx. Okay, if you calculate it, what you can find that the magnitude is equal to 41.3 kilometer and the angle is 24.1 north of east. Yes, this is end of this question. This one is also not very difficult. And
I have a question.
yes, please.
In the first place, you counted 45 degree with negative. Why the negative sign?
This one,
Yes.
because it is on the fourth region here, so you can take it minus 45, or if you want, you can take it 45. Okay, and then you can put the minus by your hand. You can do it also, or if you want, instead of taking minus, you can take because always what we use from the positive x-axis to the vector, you can use this angle. This angle is what? 360 minus 45 is equal to 3 what? 15 degree. So if you use this angle also, you will find automatically negative. Okay.
Okay. Yes. Thank you.
You're welcome. Yes. So our next example is this one: the displacement of a hogger. A hogger runs up a flight of 200 identical steps to the top of a hill, and then runs along the top of hill 50 meters before he stops at drinking fountain. His displacement vector from point A at the bottom of the steps to point B at the fountain is dAB, this is a vector, equal to minus 90 I hat plus 30 J hat in meter. So what is the height and width of each step in the flight? So what is the actual distance the hugger covers, and if he makes a loop and returns to point A, what is his net displacement vector? Okay, so we are going to find it. They give that this distance is 50 meters in the figure. And here the fountain. Fountain is here. Okay. Okay, so how can you solve it? In the coordinate system, in the figure, his displacement vector on the top of the hill is what? minus 50 meter ahead because he took this point as a 0 point. Okay, if you take this point as a 0 point, okay, from the coordinate system you can put here x minus x, y minus y. If this is a 0 point, the fountain is at minus 50 meter ahead. So his net displacement vector is from AT plus his displacement from TB. What is the AT? A, T, and plus TB. So therefore, his displacement vector, net displacement vector along the stair, but not net, only for the stairs, is equal to, how can you find it? You can send to the other side. So that displacement for the stairs is equal to displacement AB, total one, net one, minus stairs. So from A to B is minus 19. They give you in the question. AB is given, okay? AB is given to you. Minus 90 I hat plus 30 J hat. Why we take minus? Because for the displacement, always final minus initial. And minus 50 meter I hat. So this is only algebraic calculation of the vector. So I hat with I hat, J hat with J hat. So there is only one J hat component. So it is very easy. Minus 90 plus 50, because this one with this one. But here's minus minus become positive. Okay. Then plus 30 J hat. Then plus 30 J hat in meter. So what happens? Minus 40 I hat plus 30 J hat meter. This is the answer. But then you must find also height and width. What is actual distance? So actual distance means you must calculate it. For example, write them in the components and then find the magnitude. So this in front of the I hat is x component. This is x component. And y component is in front of the j hat. So therefore, we must have what? As a distance, take absolute value, minus 20, 40 and 30. But if you want, you can also convert them to the what they give you in the meter. If you want, you can convert them in centimeter. But here, no need to do it. And to find the magnitude, you must use this equation from the triangle which we study. So minus 40 square plus 30 square and take the square root, you can find the magnitude. So this is the magnitude from A to T. From A to T. So this is the distance, the length of this road. This is 50 meter. So we found that this is 50 meter. And also from A to T is 50. From T to B is also 50 because it is given in the question. So 50 plus 50 is total distance, which is the 100 meter. Okay. So this is also very simple question. And another one is this one, the unit vector of a direction. So if the velocity vector of the military convoy in this example, it is not important, this one, is V is velocity vector 4 I hat plus 3 J hat plus 0.1 K hat in kilometer per hour. What is the unit vector of its direction of motion? So how can you find the unit vector of its direction of motion? So how can you find it? Yes, you can find it easily. But first you must calculate the magnitude of this velocity vector. Okay, after that, when you calculate the magnitude of this vector, you can find its unit vector of its direction of motion from the definition of the unit vector. What is the definition of the unit vector? So, for example, for v is equal to v hat. Okay, so that we don't know the unit vector, not which unit vector, because inside this v there are I hat, j hat, k hat. So it is in the 3 dimension. So what is this? V hat unit okay, vector unit vector. This one is magnitude, and this one is vector. Okay, so how can you find the unit vector? By divide to v. Okay. Similarly to here. To find the unit vector, first you must calculate what magnitude. How can you find the magnitude? Magnitude of v is equal to vx square plus vy square plus vz square, and take summation, then take the square root. You can find that its magnitude is 5.001 kilometer per hour. After that, you use this vector and divide it to the magnitude to find the unit vector of its direction of motion, and you can find its unit vector. So if this is the vector v, what it means? It means that there is a v magnitude and then unit vector v hat. For example, here this is the v vector. Here this 4 is magnitude, and then there is a unit vector I hat. Yes, this is another example. 2 vectors are given. Okay, this is homework. You can try to do it yourself. This is simple. Only you make what you are going to do, a minus b, and then a plus b, and then find the vector c. Okay, and the solution is here also. You can try to do yourself. And this example 4 is also homework to try to do yourself, and also result and solution is given to you. Yes, another important thing for the vectors are scalar product. So what it means? Scalar product is what happens when 2 vectors multiply to each other. But when you multiply 2 vectors, there are 2 different product. One of them is scalar product and the one is vector product. First, we are going to study scalar product. This is called also dot product. Okay, scalar product is also named as dot product. And why it is scalar product? Because the answer which you are going to find, result, will be in scalar. So when you multiply 2 vectors by scalar product, at the end you can find a number which is a scalar quantity. And how can you find it? Vector A dot product vector B is calculated by magnitude of A, magnitude of B times cosine phi. What is the phi? Phi is the angle between the direction of 2 vectors. Okay, if this is the vector A and this is the vector B, phi is the angle between them. There's also the commutative laws applies, and we can do the dot product in components form. So when A vector dot product B vector, and if A vector has 3 components, for example, ax I hat, ay j hat, and az k hat, dot product bx I hat plus by j hat plus bz k hat. How can you do it? You must open the parenthesis, so ax times bx, and then ax times by. But here the important thing is, okay, so I dot I dot I is 1, j dot j is 1, k dot k dot is 1, but the other multiplications of the scalars are 0. Okay, so that at the end what you are going to do to find the scalar product of two vectors, only use ax multiplied by bx, ay times by plus az times bz. But what happens, I hat times I hat is equal to 1, so you are not going to write the unit vectors. Okay, so you can directly make summation of these numbers, so at the end you are going to find a number. Here there's an example to understand this scalar product. Three dogs are pulling on a stick in different directions. The first dog pulls with force F1 10 I hat minus 20.4 J hat plus 2 K hat Newton. The second dog pulls with force F2 minus 15 I hat minus 6.2 K hat Newton. And the third dog pulls with force F3 5 I hat plus 12.5 J hat Newton. What is the angle between the forces F1 and F2? So how can you find it? You must use the formula of scalar product. You know that the equation for the scalar product is what? F1 dot product F2 is equal to what? F1 F2 cosine phi. So how can you find this phi? You must divide F1 dot product F2 over F1 times F2. So you must use, yes, in this form to calculate phi. So first of all, you must find the magnitude of vectors. So this is magnitude, this is magnitude. So magnitude of F1 is, you must take the square of the all components and then make summation and take square root. F1 is, magnitude of F1 is 22.8 Newton. Similarly do for F2. So magnitude of F2 is 16.2 Newton. Then you must calculate F1 dot product F2. So this is one definition. Okay, this is the one definition. Also, you can calculate it directly. So we are going to find the left side directly, and from the right side we can find what is the phi. So how can you find directly? F1x times F2x plus F1y times F2y plus F1z times F2z. So 10 times minus 15 plus. So as you see that we are not going to write any more unit vectors because I hat times I hat becomes 1. So no need to write them again. Minus 20.4 Newton times 0. So it becomes 0. Plus 2 Newton minus 6.2. What happens after that? You must make a summation. If you sum of them, all of them, what you are going to find? Minus 162.4 Newton square. So this is the dot product of two vectors. So when you put in the equation, you can find that cosine phi is equal to minus 0.439. But you need to find angle. How can you find? You must take inverse of the cosine. So put this number inside the inverse of the number and find what is the angle. So the angle will be 116 degree. Yes, this is a bit different question, but this is a standard. So if you learn this way, I think in the future, if you face, you can solve it easily. Okay, so 1 minute, someone calling. Sorry. Okay, let's continue with this next example. So this is the next example. So how can you solve it? This is the work of force. This example is also very important, and in the next chapters we will study the force, Newton's law. But here we will see how can you make these calculations. So for example, when force F pulls on an object and when it causes its displacement D, we say the force performs work. So the amount of work the force does is the scalar product F dot D. And then the displacement D is given minus 7.9 J hat minus 4.2 K hat centimeter. How much work is done by third dog? So force is, how can you do it? Force 3, we know for force 1 and force 2. Yes, so to find this problem, the work is calculated by force dot product D. Okay, so if you know the force vector and displacement vector, you can make a scalar product and find work, and work is scalar quantity, but force and the displacement are a vector quantity. So they give you the displacement. Also from the previous question, we know that what is the force. So you only make, so force is equal to what? 5 I hat plus J hat plus 0 K hat. So this is the force. You know the also displacement. So you must make scalar product. So how can you make it? X component with X component, Y component. There's no Y component of displacement, so it is 0. So then K component with K component, but it has no K component, so it is also 0. So only component is what? Which one? How about here? Not I hat. This is J hat. Sorry, I did it wrongly. This is J hat. So I components are 0, but there is only J component. So J times J. So the first component is 0, I component, and also K component is 0. So only we have what? Only we have the Y component. Only we have the Y component. When you multiply them, you can find that the work is equal to minus 98.7 Newton times centimeter. And if you want, you can convert it to the joule. How can you convert? 1 joule is equal to 1 Newton times meter. And for the work or energy, we use joule as energy. So by multiply by 10 to minus 2 meter to convert it to the meter. After that, you can find it in joule. Yes, another important thing is, as I said, cross product. So what happens if you multiply two vectors by crossly? So this is cross product or vector product. So the equation for it is A cross B is equal to A B sine theta. Here, different than the scalar product. In the scalar product, we take cosine theta, but here we used sine theta. And another important thing is here A and B are also magnitude, but you can find also the magnitude of the cross product here, because for the cross product, this is a vector product. So at the end, you find vector. So and it as a component. So what is this theta? Theta is the angle between A and B vectors. So cross product of any parallel vectors are 0. So if x component gives you 0. Okay, like this one. I hat cross I hat is 0. J hat cross J hat is 0. K hat cross K hat is 0. But if you multiply I cross J gives you K hat, I cross K give you minus J hat, and J cross K gives you I hat. So cross product is maximum for perpendicular vectors like x and y, and cross product of Cartesian unit vectors are here, you can see. And another easy way to calculate the direction of the cross product is you can make a circle like this and you say that I, J, K. And when you are going to this direction, which is the counterclockwise, CCW, you take positive. But when you go to the clockwise direction, take negative. What it means? It means that I cross J, when you make multiplication like that, I cross J, it becomes K. But when you go to clockwise direction, like J cross I is negative K. Okay, so if you multiply two unit vectors, you will find the other one, third one. But I cross J gives you K hat, but the opposite one, J cross I, gives you minus K hat. Okay, this is also important point. And here you can see that easily. And if you want, you can use the right hand rule. So C perpendicular to the both A and B. So place A tail to tail, right hand, not left hand. Use the four fingers are pointed along the first vector A. Sweep from first vector A into the second vector B. Throw the similar angle between them, and your outstretched thumb points the direction of C. And A cross B is not equal to B cross A. It is equal to minus B cross A. This is also important point. I cross J gives you K hat, by J cross I gives you negative K hat. Yes, when we are calculating the torque, and also in next semester when you study physics 102 in the electromagnetism, we use this cross product and right hand rule. And another rule is the quantity AB sin theta is the area of the parallelogram formed by A and B. So you can use the cross product to calculate the area between vector A and B. And the cross product is not commutative. So when you change the direction, you can find negative. But you can open the parenthesis normally. The derivative of cross product obey the change rule. You can use the change rule. And also calculate the cross product like that. So A cross B is, use the, but you don't need to memorize these things. As I said that, you can draw the circle, and when you are looking the circle, you can decide. For example, here, this example, they give you two vector, A vector and B vector. A vector is 2i plus 3j. B vector is minus I plus 2j. So how can you make a cross product between them? How can you make it? First, like a normal multiplication, this one with this one, this one with this one, and then j hat with I hat, j hat with I hat, j hat with j hat. Okay. But from the rule of the cross product, we know that I cross I is 0, J cross J is 0. Okay, so I cross I is 0. So this is different than scalar product. J cross J is 0, so K cross K is 0. But when you make I cross J, you can find positive K. This direction is positive, but the clockwise is negative direction. So minus J cross I is minus K. So that let's look at to this example. 2 I hat plus 3 J hat cross product minus I hat plus 2 J hat. As I show it here, 2 I hat cross minus 1 I hat. I open the multiplication plus 2 I hat times 2j hat plus 3j hat times minus 1 I hat plus 3j hat times 2j hat. Here, if they are in on the same direction, I hat cross I hat gives you 0 from the rule. And for 2 times 2 gives you 4. And for the direction, I cross j, I cross j, and it is the counterclockwise direction, so positive k hat. So I cross j gives you k hat. Okay, so 4 k hat. Then 3 j hat times I hat, it is 3, but what is the direction? So j hat times I hat is k hat, but negative k hat because it is clockwise, but there is also another negative in front of it. Negative negative become positive, so you write positive 3 k hat. So here you see that both of them are on the k hat direction, so you can make summation. So you will find it 7 k hat. So this is a vector product or cross product. Also similarly you can do for example 6. This is similar. Okay, so you can do it as a homework yourself, and the solution is here, you can see. Another way is you can use the matrix form, but I think for now it is better to use the way which I mentioned you. Yes, this one
Sorry,
yes,
but I have a question.
okay.
So 5j multiply 5j is 0, right?
Which one? 5?
5j multiply 5j
Yes,
is
yes,
0.
yes. 5j hat times 5j hat is equal to 0.
So what if it's not 5, it's 3 multiply 5j, 3j multiply 5j. What's the equal?
Doesn't matter. The important is here unit vector. Okay.
Okay.
If j hat cross j hat, 0. Doesn't matter the number in front of them.
Can you always 0?
Yes.
Okay.
And this example 7 is homework. Here there is a 3c vector time. This is a scalar product. Open parenthesis 2a cross product b. Here I give you some hint. First you must to make always inside the parenthesis. First calculate the inside the parenthesis. Make this vector product, cross product. After that make multiply this scalar product. Those are the resultant solution here. You can check your solution. Which one of the following quantities is a vector quantity? The age of the pyramid in Egypt? No, this is a scalar quantity. The mass of a watermelon? No, mass is a scalar. The sun's pulse on the earth? Yes. This is what? This is
Vector.
yes, this is vector quantity because this is force. The number of people on board an airplane, this is scalar. The temperature of molten lava, this is also scalar. So as a summary, this is the end of the vectors. We see that there are two types of coordinate system. One of them is polar coordinate. So for the polar coordinate, we use magnitude A, magnitude and direction theta. And for the Cartesian coordinate, we use components. What are the components? X component and Y component of the vectors. And also we see how can we convert from polar to the Cartesian or Cartesian to the polar. And we study how can you write the vector in unit vector notation, I hat, j hat, and k hat. And we study how can you make addition of two vectors or three vectors. So always you must to use the rule that I hat with I hat, j hat with j hat, k hat with k hat. Okay, always you must make summation of vector in same direction. For example, x component with x component. And for the multiplication, there are three types of multiplication. One of them is scalar multiplication of a vector, like a number. If you multiply number with a vector, you can directly multiply it. For example, 5a is equal to 5ax I hat plus 5ay j hat. Another point is scalar product, but this time you multiply two vector each other. And to multiply two vectors, there are two ways. One of them is scalar product, another one is cross product. Scalar product is also known as dot product. So a dot b is equal to ab cosine phi. A and b are magnitude, and phi is the angle between the a and b vector. And also you can make the dot product. How can you do it? Ax bx plus ay by plus az bz, and I for the dot scalar product, I dot I is equal to 1. Okay, but I dot j is equal to 0. But for the cross product, it is different. You use that ab sine phi, and for cross product, what we are going to use, I cross I is 0, but I cross j is k hat. Okay, so their rules are different. So from the end of this lecture, also there are some problems. Problem 1, 2, 3, 4, 5, 6, 7, 8, and most of them are from the old exam questions. Okay, I put many, so you can try to solve them. I show you some examples, and they are same to each other. Okay, if you can understand the examples, you can easily solve these problems. So they are not difficult. And also, this week you did a lab experiment, but next week you will have a tutorial section. Okay, and also your lab assistant will solve you some problems related to units and also vectors. Okay, so please attend the tutorial section and try to understand these tutorial problems. So if you have any question about these problems and also examples, you can ask me whenever you want. Yes, so have you got any question?
Thank you.
Okay, thank you very much and have a nice weekend. So see you next week.
Doctor, just I will ask you one question.